Hello everyone, this is Dr. Webb, and in this video right here we're going to use the chain rule to take derivatives of roots. So that's just what I said. We're going to use the chain rule to figure out how to get derivatives of roots. So let's start off with just square root of x, and the important thing to remember is that if we square the square root of x, we get x back. Okay, so how can we use this in the chain rule? Well, here's the chain rule. We're going to think about f as being our outside function. G is our inside function. And so when you take the derivative of g plugged into f, what do you get? Well, you get g plugged into the derivative of f. So it's the derivative of the outside with the inside plugged in. And then you have to multiply by the derivative of the inside. That's an ugly looking n. Let's make that a little bit better. Okay, so we're going to apply this right now just on the fact that we saw before. The fact that if we square the square root of x, we get x back. Okay, so we're going to take the derivative of both sides. Hopefully, this side should look easy. Whereas on the right-hand side, we're going to think about this as being something in the chain rule, right? So here, what's the outside function here? And what's the inside function? Okay. Well, often it's easiest to find the inside first. And so we look at x, what's the first, we're going from x out. The first thing that happens to x is we take the square root. And so that's going to be our inside function, just the square root of x. And then what happens afterwards? That's the outside function. Well, it's getting squared. And so that's saying our outside function is x squared. Okay. So on the right, we're just taking the derivative of x. That is just 1. On this side, well, I erased it, but we can think about f as being square root of x, g, that's not what I wanted. Our outside function x is x squared. Our inside function is square root of x. So f prime, derivative of x squared is 2x. And g, well, this is what we're trying to figure out. And so we're just going to leave g prime and try and work out what that is. Okay, so if we're applying the chain rule over here, we're going to end up with, well, I need g plugged into f prime. So I'm going to get 2 square root of x. And then multiplying that all by g prime. Okay, and so since my handwriting's pretty crappy, let's make it look nice. There we go. So this is from the chain rule. So this is 2 times x is f prime. In for x, we're plugging in square root of x. And then this is what we want. What is this? Okay, so since we're trying to get this, what do? Well, we're going to solve for that guy right there. And by doing so, we're going to divide by the 2 square root of x, and we end up with that formula right there. There's how we're going to get the derivative of square root of x. So the derivative of the square root of x is 1/2 divided by square root, or 1 over 2 times the square root of x. Excuse me. Okay, so now let's try and do the same thing with the cube root, right? So the idea with a cube root is that if we cube the cube root, we get x back. So we're going to start with the same idea. The left is still going to turn into 1. And now on this side, our outside function is we're cubing, and our inside function is cube root of x. By the power rule, when we're taking the derivative of x cubed, the 3 is going to come down, and then power of x goes down by 1. So we have the derivative of the outside is 3x squared. And so this is going to be 3 in for x is going to be the cube root of x, quantity squared. That's really bad, but it's going to look better in a second. And then multiply by derivative of the inside. Let's make that look better. Much better. Okay, and then now we're going to do the exact same thing. We're going to solve for this. So when we solve for it, we're dividing the 3 times the cube root of x squared over to the other side. And that's what we get. So the derivative of the cube root of x is 1 divided by 3 times the cube root of x squared. Okay. So these are the last two we just did, the derivative of the square root, derivative of the cube root. So how do we do this in general? How do we do this for a general nth root of x? Well, the idea is going to be exactly the same. Okay, so we're going to start off with the fact that if we raise the cube root of x, so this is just coming from the fact that x is equal to, if we take the nth root of x and then raise it to the nth power, they undo each other. Okay. And so using the exact same as before, on this side, our outside function is x to the n. Our inside function is the nth root of x. And the derivative of the outside is we take the power. This really is just rewriting the power rule. Derivative of x to the n is n times x to the n minus 1. And so left-hand side, derivative of x is just 1. The right-hand side, so this is n to the n minus 1 power. That's the derivative of x to the n. And then we've got plugging the inside in, and then multiplying by the derivative of the inside, which is the derivative of we want. So this is what we're going to solve for. And same as before, all we're really going to do, take this, divide it over, and this is what we get. This is what we end up with. So if you want to take the derivative of the nth root of x, it's going to be n times the nth root of x raised to the n minus 1 power. Okay. Well, so we've been using the power rule. How does what we're getting for the derivatives of roots, does this work with the power rule? Does this fit in with the power rule? So let's take a quick look at that. So remember, roots are really just fractional powers. So if we're taking the square root of x, we're really just raising x to the 1/2 power. Right? So when we look at the derivative of the square root of x is equal to 1 over 2 times the square root of x, we can replace all of these square root of x's with x to the 1/2. So let's do that. That looks better. Okay. And so if you look, we've got x to the 1/2 here, but it's in the denominator. So we can think about this really as being 1/2 times x to the minus 1/2. And minus 1/2 is really just 1/2 minus 1, right? And so if you notice here, we're starting off with n being 1/2. Well, what did we end up with here? Well, there's 1/2, so that's n again. And then what's the power of x? Well, it's n minus 1. So this fits with the power rule. Okay. What about with the cube root of x? So the cube root of x is really taking x to the 1/3 power. So everywhere we see cube root, let's replace it with x to the 1/3. Okay. And so down here, we've got 1/3 x, well, 1/3 x to the 1/3, and then squaring that. What do you do when you have power to a power? You multiply them together. So it's going to turn into x to the 2/3, which we can think of as being 1/3 times x to the minus 2/3. So there's 1/3 over x to the 2/3. And as I just said, this is, we can think about this as being x, 1/3 to x to the minus 2/3, and minus 2/3, that's equal to 1/3 minus 1, right? So same as before, we think about n third, 1/3 being our n. So what do we end up with at the end? We've got n there, and we've got n minus 1 in the power. So this matches the chain rule. And in fact, it's going to work in general. So if we're thinking about the general nth root, x, the nth root of x is the same thing as x to the 1 over n. So we have x to the 1 over n, replace for the nth root of x everywhere. And then if we have x to the 1 over n raised to the n minus 1, we're going to multiply those two together and end up with 1 over n x to the n minus 1 over n. And then we can rewrite this. We can bring the x to the top, rewrite it like that. So we just took the negative of this power here to bring it up, and that really just changes the sign of the numerator. And then looking at this, we can simplify that out just like that, right? And so same as before, 1 over n, that's our power. What do we end up with at the end? Our power, and then x to the, our old power, minus 1. So again, this completely matches what the power rule says. And so power rule is going to work for positive powers, negative powers, fractional powers. The power rule works for all powers. So anytime you get stuck and you just have x to a power, just remember the power rule. It's very powerful. I know that's very punny. Yeah, works for all powers of x. So here are some practice problems to work on. So one, what if you're doing x to the 1 over square root of x? Well, so how can you think about that as being a power? So this has got, this second one, you're going to need to use the chain rule. You've got 2x squared minus x plugged into the cube root of x. So how do you use the chain rule on that one? And last but not least, you've got a product here with 4x plus 3 plugged into the square root of x. So think carefully about how you need to break these down and get them done. Thank you for watching. Hope to see you soon.